Hi, I am Nate with Good Mayhem Racing, and I'd like to introduce you to my early bird Tacoma project in addition to my 3D printing manufacturing space here at home. I want to first thank the new subscribers to the channel, all the folks that are here for the 3D printing side of things. Thank you so much for the like and subscribe. That's been very cool. The folks that are curious about modifying vehicles and improving them and making them last longer than originally intended, welcome. This is also for you as well. I have a 3D printing manufacturing space here that I've been working on for the past 6 months or so. All of it has been in context to manufacturing components for vehicles. In this case, of 90s era Toyotas. That would be your Toyota Tacoma, your Toyota 4Runner, hopefully later the first generation Tundra, Sequoias, and things like that. I have a product line called Das Underlights. It is a way to have a marker light or a turn signal on a third generation 4Runner or a first generation Tacoma that gives you the ability to have turn signals when you have upgraded your bumper. A lot of the aftermarket bumpers that you can buy and install on them don't have turn signals, and worst comes to worst, they do not look good and they're usually in a bad spot. So there is a filler plate underneath most of the headlights of those years of vehicles, and that is a perfect spot for a more modern LED solution. Without further ado, for the people that have invested in my R&D effort for the Toyota Tacoma Das Underlights, allow me to give you an update in person with your products. These here are about 15 or 20 sets of the Underlight kits for the 2001 to 2004 Toyota Tacomas. All they are is a 3D printed part manufactured and designed by yours truly that physically snaps into the sheet metal location that was originally installed on the truck. The other years of the Toyota Tacoma are much more complicated. The 99 to 2000 years are much more like the 4Runners, much easier to design around. But unfortunately, the 95 to 98 years are exceptionally difficult to design around. And I've only had the chance to actually design using SolidWorks and packages like that around one of the grill ends of the Tacoma. I have yet to actually see a 95 to 99, 2000 even Tacoma in person to physically model around. Only the 01s to 04s. But all of these lights here are XK Glow. These are the 9-inch sequential LEDs. They are white. They glow white for the daylight running lights or marker lights. And from there, they also have amber that blinks sequentially for the turn signals. I have 15 to 20 of those ready here, and most of them have already been paid for. I have 24 live orders for the Tacoma Early Bird Underlight, and I have maybe one or two orders remaining for the third generation 4Runner. The third gen 4Runner was the original Underlight project of mine, and I have done over 150 of those, actually manufactured them and sent them out to customers, getting their feedback and stuff like that. And oh, yes, if you have installed your 4Runner LED underlights, again, please post them, share some feedback, good, bad, indifferent, I don't care. Just any exposure you're willing to share, I'd really appreciate it. Same goes for the Tacoma stuff, and the biggest reason why I haven't shipped these out is because of wiring. The Das Underlight product line is nothing more than my 3D printed and manufactured filler plate along with an LED that's mounted in place. This is the XK Glow 9-inch sequential LED that I talked about earlier, and you see how it only has a set of bare wires coming out of it. This is hardwired. This is ready to be soldered or butt connected to other wires to run in your car. The biggest difference between what most competitors are doing in the market and what I am doing is that I'm actually providing OEM style connectors and soldering them in myself before the customer takes delivery of it. Now, if somebody is okay with hardwiring, great, then I just ship them the assembly at a lower cost versus doing all the extra work around these. And the biggest challenge with Tacomas, apart from designing the filler plates themselves, is figuring out what wiring harness is relevant to each year. Unfortunately, the Tacomas have 3, if not 4, unique turn signal plug setups that I have to figure out how to source and manage and inventory versus the simple Toyota 2. So at best, the Tacomas will get 1, 2, and 3, and maybe 4, but I haven't gotten all of that market research done yet. That is what the Early Bird Tacoma project is actually for. So for the Early Bird Tacomas, thank you guys so much for your patience. Hang tight in there. I'm working on your stuff. I'm learning a lot, and I really appreciate your help. All of your videos, your photos, your dimensionals, physical measuring of your products for me to improve against. That has been very helpful. Please keep doing that, and expect some tracking in the following days, especially for the 01 to 04 guys. Now, the big conversation, the thing that most people have recently subscribed for, and that is the 3D printing manufacturing space. Welcome to one of the shops of Good Mayhem Racing. This thing right here, this big box container, is a VivoSun pot plant grow tent. Thank you, pot plant people, for helping the 3D printing community grow. I really appreciate that. It contains my X1 Carbon, which is a Bamboo Labs 3D printer. It's AMS, which is an automatic wire exchanger, filament exchanger, and a Creality heater. All of this is inside a tent, so all of its dust and fumes can be evacuated to the outside air. This right here is a big, giant solution for fume extraction. That is it. That's the only purpose of this big, giant VivoSun box that all of the 3D printing stuff is in. When you are printing with nastier chemicals like ASA, close the vent. Close the vent hood. If you don't have the kind that have multiple inlets, you can just leave the bottom of this open to allow in fresh air. This particular one does have a vent on the bottom of it, or at least on this particular side, that allows fresh air in, and it's on the opposite side of the carbon filter. So then there's plenty of air volume for that stuff to mix consistently. Once you are done with the 3D print, or if you're printing PETG or PLA, any of the common man materials, just back it up, get it out of your way so you can do work. 3D printing as a general rule is relatively safe for your health. However, it can outgas, as in if you can smell it while it's printing, guess what? That's physically vapors, particles in the air that are at a high enough concentration for you to sense. And some of the materials are exceptionally toxic if you use them. For example, anything with styrene in it is something to worry about fume extraction. In general, things like PLA and PETG and stuff like that, they will have a high level of VOCs at the very start of a 3D print, but afterwards it gets kind of normalized and chill. You don't really have to worry about it all that much. But anytime you are doing a printer setup like this and using it for high temp materials, ASA, polycarb, anything with carbon fiber in it, having fume extraction is a relatively good idea. As a general rule of thumb, if you're going to recirculate the air in your 3D printing space, using a HEPA filter with a carbon activated filter on top of that is a great way to do it. A lot of upgrades are available to 3D printers to make them more health conscious and a little health friendly. For example, the Voxel PLA bento box that I bought here is kind of the community's de facto standard in dealing with ASA and other nastier materials like that, because it recirculates the air inside of the 3D printer, filtering it before the remainder of it goes out. Now, when the rest of it comes out of the printer, and these things are not airtight, so any air leak or like big entrance point or opening, the fumes are going to come out of. So what do you do to prevent that from happening? Well, like I just said, a big giant HEPA filter set up in your room or a way to extract it. Upstage right is the big carbon air filter that soaks up most of the ASA styrene gases and fumes in this shop before it gets exhausted to the outside world. It's actually controlled with this AC Infinity controller here, and it's all temperature controlled. I don't even have to turn it on. It's automated, and there's a temperature probe inside here, as in I took a thermocouple, put it inside the 3D printer to control whether or not any of these filtration methods are running or not. If I'm using this to print with PLA, it doesn't need to be on, right? Now, sure, for the initial VOCs that can be exhausted, sure, all right, whatever. But for styrene and for carbon, things like that, okay, I want filtration. So when this thing gets up to the elevated temperatures, like 50 degrees Celsius and higher, that's when this stuff really starts kicking on. The other thing that I like about this from AC Infinity is that it is a industrial form factor, as in if you are familiar with a lot of the furnace control systems that actually run on thermocouples for production work like space, oil and gas and the like, this is very familiar to work with, and it's kind of cool to see a home comparable version like that that people can use in their house. +1 to the pop people who made this kind of technology available for home use. Way to go, guys. It's very useful in 3D printing. What other equipment is in my 3D printing manufacturing space? Let's get into it. This is the Pro 1500S made by APC. It is an uninterruptible power supply. I always mess up those words. But this is a true sine wave generator. It's using like an analog sine wave rather than a digital one, so the 3D printer gets clean power. It is able to power the 3D printer for about 45 minutes to an hour, depending upon what materials you're running. And for Houston, where we have a lot of dirty power, this helps normalize a lot of stuff and keeps production going. The kind of materials that I print with most of the time move, so the temperature is really a big factor. So if the whole system gets cold and then picks up from where it left off, the whole thing has physically shifted now and is no longer accurate. So this really does help with the quality of prints along with dirty power. Nice power supply. Much of the accessories you see here are cannibalized from my gondola shelves in the garage, but you can see another grow tent right there. That is my deburr area. And then you can see another shelf that has all of the finished parts ready for a final assembly and soldering. This right here is a tool chest, and it just holds all of my spare parts and accessories for maintaining the 3D printer, soldering all of the wiring together, and also soldering and bolting the underlights together. A lot of spare parts for the final assembly of the Forerunners, and I will probably have lots of those for the Tacomas too. This was my original grow tent that I used for my 3D printing, and I outgrew it immediately with my just small setup here. This 2 foot by 2 foot by 4 foot was way too small for that, but it was great for manufacturing, as in having a contained area to have all of the 3D printing trees and supports to blow off, a great spot for soldering, and oh, hi Saber, and just a way to keep the mess out of the rest of the house, because this is actually a very messy thing to do in your own home. So there's kind of a fine line between everything that you would do at a manufacturing facility and what you do as a hobby. But the major difference is how you take care of your workspace and your HSA. That really is what sets industry and hobbyists apart. This is my other gondola shelf. I just have it on a set of 2x4s because I don't have uprights to use upstairs. But you can see that I have my lights, my laminate for the people that want to have amber lenses all ready to go. And these things will get assembled inside the deburr station there. Well, that is a summary of my 3D printing manufacturing space. More data is coming soon. I'm actually going to be uploading a video specifically all about styrene testing and using a legitimate styrene gas detector, so then you guys can actually compare numbers and things like that. And hopefully that can give you some wisdom for your home, for the workplace that you 3D print with and things like that. I wish I had done a lot of this stuff sooner, but again, it's kind of transitioning from a hobbyist mindset to a commercial mindset. And this is very much somewhere in between with all of this research and development that I'm working on right now. Again, I'm looking forward to everyone's feedback. Like and subscribe. Feel free to give me a comment if you'd like to have a dialogue about any of these products. I would love to do affiliate links, but I don't know how. So if I have any here, you know I just learned how to do it. So thank you guys so much for watching. I will see you out in the desert, if not my garage, or maybe up here in my 3D space. Like and subscribe for more. This is the APC Pro 1500S. It's a true sine wave generator. That's a UPS, an uninterruptible power supply. Yeah, that's right. Okay. Pardon me. Let me try that again. Okay.